Okay, so today I'm going to have a look at the cubic formula. This is it here actually, I'll just go through it in a minute. We're going to have a look at deriving this formula, or deriving a version of it. Let's just have a look at our cubic equation here, ax cubed plus bx squared plus cx plus d. So to find x, then you just simply plug in a, b, c and d into this big monster here, and out pops your three solutions. Well, it's not quite that easy. There's a lot more to it than that, but that's generally what happens. What we're going to actually do is take this cubic equation here and we're going to reduce it down to this type of equation here. And I'll go through that in a few minutes. Now, this is called a depressed version of this thing here. Okay, so what we're going to do then is take this cubic equation here and get rid of the x squared term, get rid of the quadratic term here. So the equation will look something like this. So here we have an x cubed, we have a cubic term, we have the linear term, and the term here independent of x equal to 0. So we've gotten rid of this x squared term here, this quadratic term. So how do we actually do that? By the way, if we do that, we'll end up with this formula here, which is effectively the same as this one up here, but we've gotten rid of the b and the a has become 1. So how did we do that? So if you imagine here, what we could do is divide across by a, so this becomes b over a, this becomes c over a, this becomes d over a, and secondly we're going to get rid of the quadratic term, so the b over a will become 0. So if you look at this here, this will become 0, this term here will become 0, and we end up here with minus d over 2 times 1, which is just d over 2. And you can see down here we have a minus q over 2 here. Here this will disappear, this will disappear. Here we have a d over 2, minus d over 2, which we will be squaring. So you can see that's here, it's plus here because we're squaring it. And out here then we have a c over 3a, so that's going to be here, which we're cubing. This one here will disappear. And it's the same on the second line. This line here is exactly the same as this line up here. The only difference, these signs here. Out here we're adding b over 3a, so the b will become 0, so this term here will disappear, so you've got no term out here. So these two formulas are the same. Once you get rid of that quadratic term, you can use this formula here. And then actually we have to do another substitution later on in order to solve the cubic. But once you have your solutions, you can undo those substitutions, if you like, twice to get your final solution back up here. But anyway, the first thing we've got to do is try to get rid of this quadratic term. So how are we going to do that? To just show you what we need to do here, let's have a look at this here. Now this is a cubic graph, and I have it down here actually. It's 4x cubed minus 3x squared minus 3x plus 2, and there are some points in here that the program has slotted in. It has the 3 roots here, 3 real roots in this case, and it has the local minimum, the local maximum point, and it has this point here which is called the point of inflection, which is important. Now the point of inflection is just the point where the curve changes from concave down to concave up. Or if you think about the tangents, you've got tangents on this side of the graph all the way around here, up along here, down along here. But once you reach a point of inflection, the tangents switch sides, they come over onto this side of the graph. So all your tangents will now be on this side of the graph. The other thing you can think about is that it's the center of symmetry, if you like. I know this graph is not exactly symmetrical, but if you put a pin there at D, what you can do is rotate this graph around 180 degrees. This point here will end up here and vice versa. So it's kind of a center of rotation, if you like. Now also it's actually the average of the 3 roots. If you add that and that, 3 real roots here, it'll give you the x coordinate of the point of inflection. That works when you have 3 real roots. It's slightly different when you have complex roots, but we won't get into that. Now, why am I looking at this? The point of inflection here is important. It's important because what we need to do is get rid of this quadratic term. So let's look at what happens if we change the coefficient here, the coefficient of the x squared term here. So I'm going to just move this slider here. It's currently at -3, so I'm going to move that until it changes to 0. So we move it up along here, and eventually we end up here at 0. Look what's happened to the point of inflection. It's ended up on the y-axis. And look down at our formula here. We have 0 coefficient for our x squared. So in other words, if we know the x-coordinate, of our point of inflection, we can use that to move the graph so that the point of inflection is on the y-axis, and that will subsequently get rid of the quadratic term. So let's just get back to our formula here. So I'm going to just look first of all at getting rid of this quadratic term here. Let's just move down along here. We're going to start with ax cubed plus bx squared plus cx plus d is equal to 0. Now what I'm going to do first is just divide across by a. So that will give me x cubed plus b over a x squared plus c over a x plus d over a equal to 0. Now I want to find the x coordinate of the point of inflection. So in order to do that, what I'm going to do is differentiate this twice, set that equal to 0, and that will give me my x value for the point of inflection. So let's differentiate. Well, here you'll get 3x squared plus 2bx over a plus c over a. If this is f of x here, this will be f prime x. And then we've got to differentiate this again. Get the second differential here, that will give me 6x plus 2b over a. And this is our second differential. So in order to find the x coordinate of the point of inflection, what you need to do is set this equal to 0. So let me just move that up a little bit. So we have our 6x plus 2b over a. We want to set that equal to 0. That will give me 6x is equal to minus 2b over a. Divide across by 6. Again, that will give me minus 2b over 6a. Or finally then we'll have our x coordinate, which is minus b over 3a. So this is the x coordinate of the point of inflection. So what we really need to do now is just substitute x in our original equation for x minus b over 3a, and that will get rid of the x squared term. So that's what I'm going to do now. Right, so we have x cubed plus b over a x squared plus c over a times x plus d over a, and this is our new function. So this is equal to f of x. What we're going to do now is just substitute in x minus b over 3a. So what we're going to do is put in x minus b over 3a here, cube it, plus b over a times x minus b over 3a, I'm going to square that one, plus c over a times x minus b over 3a, and that is, this one here is x squared, this one here is just x, so then we have d over a out here at the end. And this is f of x minus b over 3a. So what we got to do is cube this here. So if we cube this, we get x cubed minus 3x squared b over 3a. Then it's going to be plus 3x b over 3a squared minus b over 3a cubed. So that's just this term here. Okay, so let's have a look at this one now. So we've got to square all of this. So I'll just leave out the b over a first, and I'll just square this. So we have x squared minus 2bx over 3a, and then plus b squared over 9a squared. Okay, so that's this one. Let's have a look at this one now. So we just got to multiply this out. So it's going to be plus c over ax minus bc over 3a squared. And then we have plus d over a out here. Okay, so let's just tidy all this up a little bit. So this is going to be equal to x cubed minus, now this 3 here will just cancel with this 3 down here. So we'll end up here with b over a x squared. This 3 here will cancel with one of these 3's down here. That'll leave us with the second 3 here, because remember this 3a is squared. So this will leave us with plus b squared over 3a squared, and that's times x. Out here then we've got minus, and we have b cubed over 27a cubed. Next one then we have plus b over a x squared. Here we've got minus 2b squared x on the top and 3a squared on the bottom. And here then we have plus b cubed over 9a cubed. Okay, and then we have our c over ax minus bc over 3a squared plus d over a. Okay, so if we have a look at this, you can probably see here that we have an x squared term here, we have an x squared term here. This is minus b over ax squared, this is plus b over ax squared, and we have no other x squared terms. So you can see immediately here that we have eliminated the quadratic term. So let's just tidy all this up a little bit more. So we have our x cubed here. Let's just move this up a little bit. So we have our x cubed. I'm going to put the x's together. So it's plus b squared over 3a squared x. That's this one here. And we have another x here. We've got a minus 2b squared over 3a squared x. That's this one here. And then we have this x out here, so that's plus c over a x. So that's all the x's together. Let's put the numbers independent of x then together. So we have this one here, so that's minus b cubed over 27a cubed. We have plus b cubed over 9a cubed. We have minus bc over 3a squared, and we have plus d over a. Right, so let's tidy this up a little bit further. So we have our x cubed here. I'm just going to factorize out these x's here. So it's going to be plus b squared over 3a squared minus 2b squared over 3a squared plus c over a. That's all times x. These two here can be added. So we need to multiply this top and bottom by 3. So we have minus 1b cubed over 27a cubed. And here we would have plus 3b cubed over 27a cubed. So that will give us plus 2b cubed over 27a cubed. And we can just write the rest down, minus bc over 3a squared plus d over a. So this would be our term independent of x. Okay, so we can just tidy this up a little bit further. So we have our x cubed here. We have plus, these two here we can add together as well. We have minus 2 of these things here. We have plus 1 of them. So we'll end up with minus 1 of them. So I'll put the c over a first, then it's going to be minus b squared over 3a squared here. It's all times x, and this one here we've already tidied up, so it's 2b cubed over 27a cubed minus bc over 3a squared plus d over a. Okay, so that's it. We've actually done all we can do with this. So you can probably spot at this stage that this is in the form x cubed plus px plus q, and we can let it equal to 0 as well. We can let this equal to 0 because we want to solve for x here. Okay, so what have we done so far? Well, we've taken our original cubic equation, which was ax cubed plus bx squared plus cx plus d. Well, actually, I called them x1s. They were different variables than this one here. We made a substitution. We changed our x1 to a different x, and we reduced it down to this particular type or this particular form of cubic equation. This is called a depressed cubic, and you guys are probably a little bit depressed at this stage after seeing all that boring algebra, but we have our x cubed here, we have some constant times x, and then we have a constant out here with no x equal to 0. So this just basically shows that any cubic equation can be reduced or depressed into this format here without an x squared. So let's continue on to the next part of this video. So we are here with our x cubed plus px plus q. So really we have to solve for this x here. Now how are we going to do this? Well, this is where we introduce a second substitution. So what we're going to do now is just let this particular x equal to u plus v. So these are two other variables, and we're going to substitute them in for this x here. Why u plus v? Well, you're just going to have to bear with me. It does actually work out. So just keep an eye on what I'm doing and you'll see what happens. We will end up with the simpler formula that we had originally at the start of the video. So let's have a look. What would happen if we do this? Well, if we take, for example, u plus v, and we cube it, we'll get, let's see, u cubed plus 3u squared v plus 3uv squared plus v cubed. Now we can rearrange this. Let's see, we can write down the u cubed here. We have a common factor here and here, so I'm just going to take those out. So we have a 3uv. So that'll leave me here with u plus v in the brackets. Then we've got a v cubed here. So let's just put the u cubed and the v cubed together. So we have u plus v cubed on the left hand side. On the right hand side we have 3uv u plus v plus u cubed plus v cubed. Let's just bring everything over to one side. So we have the u plus v cubed minus 3uv u plus v, and then we have minus u cubed plus v cubed, and that's going to be equal to 0. Now let's just move this up a little bit, and if you look at our original, this equation here, we have x cubed plus px plus q equal to 0. Now effectively what we need to do here is solve for u and v. So we can see here we have our x cubed here. The coefficient of the x here is going to be this here, and the term independent of x again is going to be this here. So really, in effect, what we really need to do here is just solve these equations here. We have minus 3uv equal to p, and we have minus u cubed plus v cubed equal to q. So just rearranging these then, we have uv equal to minus p over 3, and on this side here we have u cubed plus v cubed equal to minus q. So really what we've got to do is solve these simultaneous equations, if you like. Okay, so how are we going to do this? Well, the first thing we're going to do here is just cube the left-hand side of this equation here. So if we do that, we get u cubed v cubed is equal to minus p over 3 cubed, which is just minus p over 3. I'll just write it like this, minus p over 3 cubed. The problem here with cubing both sides of an equation is that we're going to introduce extra solutions. For example, if you take x is equal to 1, that's a very simple equation. Our solution is just x is equal to 1. If you square both sides, you get x squared is equal to 1 squared, which is 1. You can see now that this is going to have two solutions. So it's going to be x squared minus 1, which can be factorized to x plus 1, x minus 1. So your solutions here are x equal to minus 1, x equal to plus 1. Similarly, if we cube this here, we are now introducing an extra 2 solutions. So again, I did this in a previous video, but you've got x minus 1, x cubed minus 1 cubed, and again that can be factorized as x minus 1 times x cubed plus x plus 1. And then this is one solution here, x is equal to 1, and what you've got to do here is just use the quadratic formula to solve this, and you'll get your 2 complex roots. So what I'm trying to say here really is that when you cube both sides of this equation here, you're introducing extra solutions. And that's what's going to happen here at the end. We'll actually end up with 9 solutions. We know that there are only 3 solutions to our cubic equation. We've got to pick the 3 correct solutions. Okay, so anyway, to get back to what we were doing, let me just get rid of this for a second. What I'm going to do then is just substitute this in here. And what we should end up with is a quadratic equation which we can solve using the quadratic formula, or which we can deal with at least. So let's do that then. So we have minus q is equal to u cubed plus v cubed. What we can do with this equation is multiply both sides by v cubed. So we're multiplying both sides by v cubed. So the left hand side will become minus qv cubed. We'll have u cubed v cubed plus v to the power of 6. So now we're going to do our substitution. We have our u cubed v cubed here, and that's equal to minus p over 3 cubed. So we're going to substitute that in now here. So we will have minus q v cubed is equal to minus p over 3 cubed plus v. I'll actually rewrite this as v cubed squared. Let's just bring everything over to one side because we have a quadratic here. So we have v cubed squared plus qv cubed, and then minus p over 3 all cubed, and this will be equal to 0. Now this is simply a quadratic in v cubed. You can see we have a v cubed here, which is squared, q times v cubed, and this has no v cubed out here, equal to 0. So this is a quadratic, and what I'm going to do to this is just apply the quadratic formula. So we have v cubed then is just going to be equal to, v cubed is going to be equal to minus b, well b is q, so it's going to be minus q plus or minus the square root of b squared, so that's going to be q squared, minus 4 times a, well a is just 1, and c then is minus p over 3 cubed, and this is all over 2a, which is 2 times 1, which is 2. Okay, so let's just mess around with this a little bit. We have v cubed here. We've got our minus q plus or minus the square root of q squared. Well, that's just q squared. Minus times minus here is plus. This, remember, this is cubed out here. So we have 4 times p cubed. So it's going to be plus 4p cubed over 27. And this is all over 2. Okay, so let's just mess around with this one a little bit. So we have v cubed is equal to, I'm going to put this minus q over 2 here. So this is minus q over 2. We have our plus or minus. Now, with regard to this part of our fraction here, I'm going to change that 2 to a 4. In fact, I'm going to change it to the square root of 4. So really what I'll end up with here is q over 2 squared plus this will become 4, and it will cancel with this 4 here. So really we'll end up with p cubed over 27. So that's just going to be p over 3 all cubed. Now this is v cubed, so what we've got to do is cube root both sides. So we have v then is going to be the cube root of minus q over 2 plus or minus the square root, put a 3 here, this is cube root, square root of q over 2 squared, should be a square here, plus p over 3 cubed. And this is really the formula that we started with at the beginning. Not the big one, but the second one, the reduced version of that big formula. Now if we solve for u, if we had to solve for u, we'd have gotten exactly the same result here. So really our final formula, if you like, is we would need to add u and v. So it would be u plus v, which is x, is going to be equal to the cubed root of minus q over 2. Let me just leave out these signs for the moment. I'll put them in a second. You've got q over 2 all squared plus p over 3 cubed, and then we'll add, let's say this was v for example, then the second one will be u, so we've got to add that. So it's going to be the cubed root. Same thing again, q over 2 plus or minus here, I'll talk about that in a second, and we also have the q over 2 all squared plus p over 3 all cubed. Now what about the signs here and here? Well, we have two signs here for v, we'll have two signs for u, so we have a combination of plus 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 minus 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 plus, and what you'll actually find in practice is that the version that will work is plus minus or minus plus. So in other words, you've got to have two different signs here. Okay, and that's where the reduced version of that big monster formula that I wrote down initially in red comes from. So looking at the equation that we finally came up with, it's broken down into two sections. We have this section here and we have this section here. So one is u, one is v. It doesn't really matter which one is which. For this one here, we have three solutions. For this one here, we're going to have three solutions. We have to add those together to find the solutions of our equation, find our x. And now the problem here is that we will have a total of 9 possible combinations, 9 possible combinations of pairs of u's and v's. So for example, if our principal cubed root of this side here is u and the principal cubed root of this side here is v, to find the other two cubed roots of this side of our equation, what we're going to do is multiply the u here by omega and then multiply it by omega squared. Omega being the complex root of unity. I did that in a previous video. Same over here, so you've got v, you've got to multiply that by omega, and you've got to multiply that by omega squared as well. So these will be our three roots of this part of our equation. These will be our three roots of this part here. So you can see here we've got to add these up. So you can add this u to v, you can add this u to v omega, you can add it to v omega squared, you can add this one to this one, this one to this one, and so on. So you end up with 9 possible combinations. So which ones work and which ones don't work? Well, happily enough, it has been worked out for us, and what you'll actually find is that if you combine these two and these two and these two here, they will give you the three roots of your original equation, the non-depressed one, the happy equation if you like, the one in red at the very beginning. These three will give you the solutions of the depressed equation that we had at the very beginning. So what you've got to do is really to find these u's and v's here. You've got to find the u and v that satisfy these equations. Remember this equation back here was formulated from these two equations. P is equal to minus 3u, v and q is equal to minus u cubed plus v cubed. So really you've got to find these values here that will satisfy these equations. Okay, so once you've done that and you've added the various pairs, you have x. And remember that uv then, u times v, is going to be equal to u omega times v times omega squared, and it's also equal to u omega squared times u times omega, and that's going to be equal to minus p over 3. Also then your x then is going to be equal to u times omega plus v times omega squared, or it can be equal to u times omega squared plus v times omega, or just simply v plus u plus v. So these are our x's here. So we want to find x, okay? We want to find our original, we actually want to find our original x1. So we found x, so this is going to be our x here, our 3 x's actually. So how do you go about finding your original x1 then? Well, remember that x1, our original x1 in the non-depressed, the happy equation if you like at the very beginning in red, is equal to x minus b over 3a. This was the substitution we made at the first step. So all you've got to do then is subtract b over 3a from each of the above to find x1. So you've got to subtract b over 3a from these three, and that will give you your x1, your solution to your original non-depressed cube. And that's really it for this particular video on the cubic formula. Hopefully I'll try and get a video done on a practical example of this as well. See you in the next video.